In this period of lockdown, all things have gone virtual, right from studies to office work. As a part, you may be attending your schools, colleges, or even classes online. Here's one more attempt by me, Pooja Agarwal Bangar, for my students. You can subscribe my channel for regular videos or even mail me or comment below if you have any doubts regarding the subject or connect with me on Instagram. I have been in this profession right from past 10 years with zeal to equip my knowledge with technology. So let's start our today's session. Today we are going to start with the new chapter Solid State. This is the first chapter of chemistry in your 12th standard. So come on, let's begin. Basically consists of many topics which you must have learnt in your lower standards. But then there are certain things which need to be rebrushed. So the first thing, the smallest constituent particles of various solids are atoms, ions or molecules. Now there are various types of solid. They are mainly crystalline solids and amorphous solids. Basically crystalline solids are those solids like if you dissolve sugar into water, it is a crystalline solid. An amorphous solid best example is if you take talcum powder and you try to dissolve it into water. You cannot dissolve it in water, but you will see it as separate lumps suspended in the water. So talking about crystalline solids, there is regularity, periodicity in the arrangement of constituent particles in crystalline solids. The ordered arrangement of particles extends over a long range. They have sharp melting point and sharp boiling points, plus they are anisotropic. For this, see my next slide. Then examples can be taken as NaCl, gold, copper, materials such as diamond, graphite and ceramics. For amorphous solids, they are randomly arranged. The particles do not have a long range ordered structure, but they have a short range ordered structure. They do not have sharp melting points. They melt gradually over a temperature, that is between, you can say, 50 to 60 or 55 to 60, but you cannot define a single temperature. Plus they are isotropic. Example are glass, plastic, rubber and tar. Now classification of crystalline solids. Crystalline solids are classified as ionic solids, covalent network solids, molecular solids and metallic solids. Talking about first ionic crystals. The constituent particles of ionic crystals are charged ions. Now here charged ion means they could be anions also or cation also, and the cation and anions always differ in size. Each ion of a given size of charge is bonded to the ions of opposite charge around it by a Coulomb force. In other words, the particles of ionic crystals are held together by electrostatic forces of attraction between oppositely charged ions. And the best example of an ionic crystal is NaCl, because sodium donates one electron to chlorine, so it becomes positively charged, while on the other hand chlorine accepts that one electron and becomes negatively charged. So the attraction between positive and negative ion of NaCl leads to electrostatic forces of attraction and formation of an ionic crystal. Ionic crystals are hard and brittle and they have high melting points. They are non-conductors of electricity in solid state. However, they are good conductors of electricity when melted or dissolved in water. Whenever you think about ionic crystals, the first basic thing or the first example which should strike your mind should always be NaCl. See, when NaCl is present, it is always hard and brittle. It has a high melting point and it cannot conduct electricity. But when the same NaCl is dissolved in water, it undergoes dissociation to form Na plus and Cl minus ions, which lead to good conductor of electricity, making it as a good conductor for electricity. Next is covalent network crystals. Now the basic difference between ionic crystals and covalent network crystals is that covalent network crystals will be having covalent bonds in them. We already know what are covalent bonds. Covalent bonds are the bonds which are formed due to sharing of electrons by both the species. Okay. So the constituent particles in covalent network solids are atoms. The atoms in these crystals are linked together by continuous system of covalent bonds. The result is a rigid three-dimensional network that forms a giant molecule. The entire crystal forms a single molecule. Now as a result of rigidly bonded structure in covalent network crystals. They are very hard. In fact, they are the hardest and most incompressible of all materials. Example is diamond. They have high melting and boiling points. The electrons are localized in covalent bonds and hence are not mobile. As a result, covalent bond or covalent solids are poor conductors of heat and electricity. Example, diamond, quartz, boron nitride and carbondium. Molecular crystals. Substances such as Cl2, CH4, H2, CO2 and O2 on solidification give molecular crystals. Crystalline organic compounds are also called as molecular solids. The constituent particles of molecular solids are molecules or unbonded single atoms of the same substance. Now, the bonds within the molecules are covalent. The molecules may be held by various intermolecular forces of attraction. So here when we talk about molecular crystals is that anything which makes up a molecule and the molecule is in a gaseous state. So those are called as molecular crystals. That is, if you take any kind of a gas, it is in molecular state, and when you solidify it, it becomes a molecular crystal. In this category, you can even have ozone also. You have methane. Then you can even have which gas you can say carbon dioxide, carbon monoxide, sulfur dioxide. All these are part of molecular crystals. Now, which are the forces which exist between them which make them molecular crystals? First is weak dipole-dipole interaction. Firstly, talking about what is a dipole. A dipole is a species in which you have a positive part and a negative part. Now, how can in a same molecule you have a positive part and a negative part is that if you take example of HCl molecule. In HCl molecule, H is highly electropositive and Cl is highly electronegative, and the shared pair of electrons between HCl therefore shift towards the chlorine, and therefore chlorine becomes negatively charged and hydrogen becomes positively charged. Thus a dipole exists between them, that is a positive and negative in the same molecule, so it is called as a dipole. So weak dipole-dipole interaction in polar molecules such as HCl, H2O, SO2 which possess permanent dipole moment. Second is London forces in non-polar molecules. Now those non-polar molecules will be taking place which are exactly the same. Like if I talk about Cl2, H2, O2, they cannot have difference in electronegativities because both the atoms are almost, not almost, they are always the same. So these forces are involved in monoatomic gases like argon, neon, etc. These substances are usually gases at room temperature. Now the third force which exists is intermolecular hydrogen bonds. Now intermolecular hydrogen bonds are present in ice, that is H2O, and ammonia, HF and so on. Because of weak intermolecular attractive forces, now this is a table which you can even see in your textbook. Ionic solids, covalent network solids, molecular solids and metallic solids. The next topic that we will study is a unit cell. See, what is a unit cell? The smallest repeating structural unit of a crystalline solid is called as a unit cell. I give you example of a cube that we keep on playing. So from that, the smallest square or single unit which you have will be called as a unit cell. Okay, when the unit cells are stacked together, they generate a crystal, and each unit cell shares its faces, edges and corners with the neighboring unit cells. So the dimensions of a unit cell along the three axes are denoted as A, B and C, and the angles between the axes are represented by symbols alpha, beta and gamma. You can see in the diagram the angle between A and B is given as alpha, the angle between B and C, the angle between A and B is given as gamma, the angle between B and C is given as alpha, and the angle between C and A is given as beta. How to remember this? See, A, B, what is left is C, so it will be a gamma. So that which letter is left, that forms a particular angle over there. Like for example, if you take axis B and C. Now axis B and C does not contain a A, so the angle between them will be an alpha. Okay, so it makes it easy for you for marking. Types of unit cells. The first one is primitive or simple type of unit cell, in which it consists of all the constituent particles present at its corners only. Next is body centered unit cell. In this type of unit cell, one constituent particle is present at the corner, that is like the primitive one, but one additional is present in the body, that is exactly in the center of the body. Next is face centered unit cell, that is you have a unit cell and at all the faces you will be having a single molecule or a single particle which will be present at the center of the face. Next is base centered unit cell, like in face centered unit cell you had each unit cell and a particle present at the face. Here it will be present only at the top and the bottom in the base centered unit cell, as you can see in the diagrams. If you like our video, kindly hit the like button, press the bell icon and subscribe to our channel. Suggestions and improvements are always welcome through mails and comments. Thank you.